let me show you some project charter. Yes. We've seen the Pareto and all those things. Let me move those slides. This and all we are done. And the lean slides will also be shared with all of you. So you can go through that. And of course, this and all we discussed in with the help of Minitab. Yes. Now coming to the project charter. Yes. So project charter is nothing but a template, a one-page format that will put all necessary information in a crystal clear format so that the sponsor can quickly understand what exactly you are trying to do in your project. So these are 6 primary elements: business case, problem statement, goal statement, scope statement, timeline, and team members. So elements of a project charter and some example cases. 6 elements. I think now I need not explain because I've already thoroughly explained in the morning. You all know what is business case. Am I correct? It will talk about 3 things: financial benefit, non-financial benefit, and what is the other one? If you can add, strategic alignment of the project. In fact, Ocean Country is a document that is prepared by the Quality Council, high-level committee, to ensure the projects are aligned with the strategic priorities of the organization. We will be teaching you the same tool in the MBB program, which is the Ocean Country. So,
if you don't mind, can you go back to the 2 slides? I missed out looking at them.
Which one? I have not covered anything.
Okay, elements of project. All right. Okay, this second slide.
And then 6 elements. And then we are just trying to see the business case. And already we have discussed very, very clearly in the morning. So even this examples, whatever I'm showing here, might look inferior right now because we discussed in detail in the morning. Look at the business case here. Are you convinced with the business case? June 21 to 22, there is an average rejection of 2.8. However, with a target rejection of 1%, we can save 40% annually. What is this business case talking about? Is it talking about financial benefit? Or is it talking about non-financial benefit? Or is it talking about the
financial benefit?
Financial benefits.
Financial benefit.
Financial benefit. Non-financial benefit can also be added, and a line explaining or confirming the strategic alignment can also be added, right? So that it will look really great. So that's business case. Problem statement. It contains a brief description of the pain being experienced by the organization or by the customer. Always it is related to the VOC, the CTQ characteristics. It must include the current state, for example. So here, what is the CTQ or CTB? CTB is rejection rate. And the cost of poor quality is also added here, and some additional information is also given here. That means this is called problem description. Goal statement has to be specific, measurable, achievable, relevant, time-bound. So please check whether all 5 principles are covered. Achieve 3.8 sigma level from 3.4 by demolishing 65% of the current rejection rate within 180 days. So this is an example of a goal statement. Another example of a goal statement. And here in the second one, what are they trying to improve? Employees motivation score. Yeah, probably a HR department project. So they wanted to improve the employee motivation from current 42% to 70% by end of the 3rd quarter 2017. So this is another goal statement. Scope statement. Here in this particular problem, it's again a manufacturing related project. You can see length undersize rejection. Rejections due to length undersize and cup bulb D-shaping, they are considered. All other rejections are not considered because within the same shop floor, different types of rejection happens. So our project is addressing only 2 rejections, right? So this is scope statement, in scope and out scope. And timeline, always the starting, define, measure, analyze, improve, control, and then the completion date. You can have some timeline. People know Six Sigma projects, a lot of uncertainty involved. So, but we are trying our best to stick to the timeline, stick to the budget and everything. But still, people know there will be challenges, there will be uncertainties, some changes happening. And so project charter should be considered as a living document, right? At the end of every phase, if there is a major change, deviation observed, then it will be reapproved. Team members, we talked about it. All these members have to be, part of the project team. And this is a typical project charter. This is a project executed by one of our MBB. So he reduced the welding defect. And this was done in Oman. And the business case is written in Oman Riyadhs, goal statement, project plan, team member, and the opportunity statement, nothing but the problem statement. The rejection rate is already 0.45, right? 0.45. And from 0.45, their goal is to ensure zero defects, right? So that is the, since it is already close to zero, they set a target of 0. And then the scope is also written very clearly. And then this is again another project charter, reducing the rejection percentage from 2.8 to 1% and leading to savings. And you can leisurely go through all of this. Were already shared with you. You can go through that. And this is again project charter for a piston manufacturing company, and where the outer diameter chip issue was actually reduced. So there is no compulsion that project charter should be in a specific format. No, it's not required. So whichever, if your company is having already a format, you can use that. Otherwise, you can create your own format also, right? So, but we can share some templates of project charter, which you can use it according to the requirement. So these are some add-ons, additional informations with the project charter to impress your sponsor, to impress your project team, and to bring clarity, right? So project team structure, overall involved, you can show the sponsor, champion, project leader, team member, and with a kind of layout. And similarly, for each and every team member, their roles and responsibility can be defined and shared. And all these things will bring more clarity. People will understand their responsibility as part of the project team member and then try to deliver. And this is a project schedule, nothing but a Gantt chart that will clearly show the sequence of activities. So sometimes there will be parallel activities requiring some pumping of additional resources. So all these things are illustrated.
What do you call this, sir?
This is called Gantt chart, G-A-N-T, Gantt chart. That will show you, the activities, various activities, the starting stage, ending stage. For example, the define starts here and goes on for 3 weeks. Then 4th week, the measure starts, goes up to 6th week. Then 7, 8, 9, 10, 11 is analysis. And in the 10th week itself, the improve phase also parallelly happening. And then similarly, the 13th week, the control phase activities started happening. And then we close the project by about 16th week or so. So this is called Gantt chart. So hope all of you can prepare your project charter now. Am I right?
Yes, sir.
So please
Yes,
do prepare a project charter, and if possible, we can get it reviewed during this, sometime during next week. Just team-wise. Hope you remember you are divided into teams. Please try to have some interaction within yourself, preferably team-wise, or you yourself form a team, and then you can start working together as a team. So try to create one project charter which should have a proper clarity on all these elements, and then we can get it discussed in our training session itself. So one more important tool in the define phase. This is the last tool according to the agenda. Sipoc. Sipoc is actually an acronym standing for supplier, input, process, output, and customer. So this will help you to understand the process that is responsible for the failure. And then this will also help you to visualize all the stakeholders of your project. Let us start with a simple case as always. So here you are seeing a Sipoc diagram of a, you can see just, and see, tell me what process it is. Look at the process here, steps here. What is happening here? Are you able to find out?
Credit card purchases.
Credit card.
Yeah. So someone has applied for a credit card in a bank, and then definitely the bank office officials will be processing your application. First of all, they will enter your details, and then they will check whether you are eligible for a card. And then if you are eligible, card will be ordered, and then an email will come stating that your application is approved and card dispatched. Card will be dispatched within 10 days or 14 days. And once that email communication is done, then the paperwork is completed. See here, here it is, it is credit card order processing, isn't it? They are just, the application is processed. Once this process outcome is, it will just communicate whether the card is, whether the application is accepted or not. If it is accepted, then the next process will get triggered. What will be the next process? The card will be dispatched, isn't it? The dispatch will start. So here we are very, very specific. Only the order processing is in the scope of this project. And only those steps are indicated. How many steps are shown here? 1, 2, 3, 4, only 5 steps. But in reality, there can be more than 5 steps. Because we are in the initial stage of define phase. We have not even started, collecting data and other things. We are just letting the sponsor know that this is the process we are going to work on. And for this process, what are all the input that is required? Who will give the input? They are called a supplier. And the process, what it will produce, the output, and who will receive the output. So this is called a high level map of the process. A 10,000 foot view of the process we are going to improve. Now one more example. So what is the process here? What is the process here?
Making a photocopy.
Making a photocopy. Again, a very, very simple process. So what do you do first? You first place the originals, right? You put originals, and then you close the lid, and then you actually adjust the setting. Then you press the start button. Then finally, you remove the originals and the copies. Now, the photocopying is the process. What are all the inputs you may require for photocopy? The copy
Original certificates.
Originals, and you need toner,
Paper.
and the copier machine, and you need power to run the copier machine. All of these are called input. Now, who will provide the input? For example, original, who should bring the original? You yourself should bring the original. Suppose if you want to take the photocopy, you will be having the original. So you are the supplier, right? And then now the output is photocopies. And output will be received by, you may require some copies. You may want to file some of the photocopies. And then sometimes you may want to submit the photocopy to maybe your management. Or sometimes you will put the photocopy on a notice board. Accordingly, their requirement will vary, isn't it? So whatever output that is coming out, that should meet this requirement. So all of these are customers. All of you understand? Can I write notice board here? Can I write notice board in the customer column? Can notice board be a customer?
Yes.
Right. So then only we realize what size output is required, in what format output is required, whether the output has to be in a bigger size or a smaller size. Anything, that is receiving your output can be considered as the customer here. Now let's discuss about again one generic case. This process is pizza preparation and delivery. When I say pizza preparation and delivery, we are trying to talk about two things. We are not only trying to improve on the delivery time, but we are also trying to improve on the preparation.
Preparation.
Why? Because customers are complaining about delay in the arrival of the pizza. There are several outlets you are running, and almost maybe let's say in a particular outlet, so many complaints are coming about delay in the delivery of the pizza. So why pizza is delivery is getting delayed? Maybe the problem might be due to the delivery boy or due to the making of the pizza. So we are going to improve the process behind the delayed delivery, and so we need to visualize the starting point of the process and the ending point. Now, without looking at my slides, please tell me what is the starting point of the process which we need to improve. Imagine you have a pizza outlet. There is an outlet manager, there is a cook, there is a delivery boy, and there is a provision to book the pizza. I mean, order the pizza. People can order through the mobile app or can order through website or whatever manner, right? So ordering mechanism is available. Now tell me, what do you mean by, the delay in the arrival of the pizza? So what is the process we should improve so that the delay will get, the delivery time will get reduced? What
Placing
is the
order.
starting? Yeah, placing order. Very good. So the starting point is placing order. Ending point?
Delivery.
Delivery.
To the customer.
Delivery to customer.
Yeah. If you place order, the process starts. And if you receive the pizza, the process gets over. So we are going to improve the activities that are happening in between these two, starting point and ending point. Customer places order and delivery boy returns back to the store. So now when someone is placing the order, who will receive the order? Imagine you are running the outlet, pizza outlet. Someone has placed the order. Who will receive the order in your store?
Receptionist.
Maybe the cashier, store manager, or the same person can be the store manager and
Maybe the receptionist and the cashier or the floor manager.
yes, exactly. So now that person knows money is paid for a particular pizza. So see here, the store cashier is the customer for the first step. Am I right? And now what he gets a payment. He gets cooking instruction. He also get delivery instruction, because anyone who is placing the order, they normally give, pay the money. They have to tell what kind of pizza they want, what topping they want, and to which address the pizza must be delivered. So all of these things are coming to the particular person who is cashier. Now what the cashier will do, the next stage, he will transfer the details to the cook. Right? He will transfer the details to the cook. So pizza, again the topping, and similarly, the pizza cooking details will go to the cook and delivery details will go to the delivery boy. Am I right?
Yes, sir.
So that is why both
Yes.
people are mentioned as customer here. Pizza making personnel and then delivery making personnel. So the pizza making person, the chef will receive the pizza detail. The delivery person is now alerted. Now that there an order has come, so he has to be ready with his vehicle and other things. And now the person has started cooking the pizza. And now for cooking of the pizza, yes, he requires the pizza base, the toppings, some vegetables and all those things. And here in that outlet, the cooking assistant can actually, prepare all of this. So sometimes the cook himself has to arrange all of this. Then he himself will become the supplier. And then the pizza is cooked. The cooked pizza now goes to the packing person. See, I have segregated everything. I am telling, for everything there is a person. But sometimes in outlet, there will be only one cook who will act as the assistant, who will act as the packing person and everything. Only there will be a cook and then there will be a cashier and there will be a delivery boy. That's all. So you need to apply the situation properly. And now the pizza is cooked and the packing person is able to pack the pizza. And then once the pizza is packed, it comes with the pizza in a proper pack, along with invoice, along with the delivery details. And now that is handed over to the delivery person. Now the delivery person collects And who will hand over, for the delivery person, probably no, the cook himself will be handing over it to the delivery person. And now the pizza is delivered. In order to deliver, he need the packed item and the vehicle and all those things. So he himself has to manage all of this. So he himself acts as the supplier. Now the ordered pizza is the output, and that is received by the customer. The one who placed the order. You can also say end user here. And now the delivery person returns. Are you now able to see all the activities that is happening from order till delivery of a pizza? And if you really wanted to reduce the delivery time, you may have to work on this process. You can find out where and all the time is, getting wasted, and how can you optimize and ultimately the improvement. You will make some changes in the process. So thereby the delivery time will come down. So ultimately right now, let us not worry about the solution to the problem. Our interest is to visualize the process that is actually connected to the problem. Is that the delivery time really depends on this process? All of you are sure?
Yes.
Isn't it? Exactly. That means now look at the right side. You see various people involved in the process. Store cashier is involved, the cook is involved, delivery boy is involved, even the customer is also involved. And on the left side, you are seeing cooking assistant, you are seeing store manager, and all these people are acting as the supplier. Whether one is a supplier or a customer, he is connected to the process. And probably we will try to involve them properly in our project. Thereby, we will be able to reduce the delivery time. Any question here? Any question?
So here, hello.
Yes.
Yeah, here from store cashier to this cooking instruction, we are giving to instruction to the cook. Now currently we make it as a digitalized. So we have to reduce it. Once we bring the order, immediately, simultaneously, what a customer need, directly move to cooking department.
Very good.
The cooking make ready once, immediately that delivery time, they instructed directly to the cashier. For now digitalized. So the time consumption is reduced. So the delivery time also reduced.
Yes, that's true. They have automated some of the steps, isn't it?
Yes.
The cashier need not, separately carry the
Store
information to the
manager,
cook.
cooking as
Automatically, simultaneously, when he receives the cash, and the kitchen is also informed about the order. The next item in order received for one pizza. So without the store cashier doing anything, the information is reaching. So what Saravanan is trying to say is, sir, the second step can be eliminated, isn't it?
yes.
Sir, same like that.
Yeah,
same like that. That pizza is cooked. That cooking person were topping the pizza sauce or like that. Like the last preparation. These are all things can do one person for a cooking person can do this.
agreed. See, it depends. See, at one day, there won't be any cook also. Cook also won't be there in the outlet. Possible, isn't it?
Yeah.
One day, if you place an order, automatically the pizza base will go to the oven. The toppings will go automatically, and only the delivery boy will be there.
Yeah, you have elaborated everything, sir. Right, sir?
Correct.
No. See,
No,
this is
automation.
the evolution. See, gradually things will improve.
Sir,
Yes.
already in Bangalore, there is a idli point is selling like that.
Yeah,
automated.
dispersing center is there. Automatic
Yeah.
dispersing.
Not only idli,
This
chapati,
improves. Yeah, exactly.
chapati, parota, everything is there. Now automatic. Only you put the raw material, getting the chapati outside.
Yeah.
Same way we have for Japan, right? Also.
Yeah.
True.
No. Even in India, it's there.
Only
Lot of,
eating is
even
not automatic.
Yeah, yes, correct.
Eating only we have to do it ourselves.
Can you think of a similar situation in your process? So making idli is possible, making pizza is possible, parota is possible. But how about your products? We are moving towards that. Can you see that, all of you?
Yeah.
We are trying to move towards that condition, a situation where the human intervention is very, very minimal. That means you are thinking of 100% automation, and finally digitization. Now customer also don't have to come.
No, this is one for one thing. We are getting advantage. It is going to disadvantage also same procedure.
Yeah. People will measure everything and then take a call.
Yes.
Plus will be there, minus will also be there. So, all right. See here, this is about storage process. So problems related to the storage of the ingredients and the pizza items, that actually requires an improvement in the storage process. So what Sipoc is telling you is, it is telling you to focus on improving the right process that is actually responsible for your failure. So we just understand supplier input, process, output, and customer. And sometimes people call it copies. They read it from the end. You can read it from the left, it is Sipoc. If you read it from the right, it is copies. And here is a Sipoc for a welding process improvement. And see here, Sipoc won't include all the steps. It will show only critical steps. If you want all the steps, you need to go for the process flow chart. Or in a lean project, we will be going for a value stream map, where we try to show each and every piece of movement. But here all the critical steps are indicated, because ultimately we just wanted to understand the right process that has to be attended, and then all the important stakeholders involved in the process. So this is for the welding.
Sir,
Yeah.
can you please tell me that what is the difference between Sipoc, between PFC, process flow diagram?
Sir, I have given in the chat box.
Sir, process flow diagram involves also a decision making flow will be there
Process flow
included in that.
is for lean study. You want to eliminate the waste in a process flow.
Okay.
If there is a waste of movement, no, you should avoid that. If there is amount of inventory lying idle, then you should eliminate. So that is called lean study is useful when you use a process flow, and Sipoc is for fixing the responsibility. Beforehand, everybody knows what is his responsibility and what is the input, output, and who is responsible for supplying, who is responsible for receiving.
Okay. For example, consider your own the training process. What is that you have done first? You made inquiry, right?
Yes, sir.
You inquired and then connected with our people, and then you made the payment. Then you filled up the application. Then you are here in the you attended the induction. Then you are attending the training program. Then you are going to write the exam. Then you are going to get the certification. How many activities? 8 activities, isn't it? We just counted. But when I actually draw a complete process flow diagram, it will be more than 8.
The decision making will be involved.
Something in between, the schedule has to be prepared, isn't it? And then the trainers have to be arranged. And one trainer will not be available on a particular day. So all these things, everything, will come into picture in your process flow diagram. However, in a Sipoc, only critical steps will be indicated. 5 to 8 steps, that's all. Registration, fees payment, training, examination, certification. It looks very simple. That's how Prabhakaran would have explained. The course is very simple. You just join, that's all. Isn't it? So you come here and then you take your certificate and then you will get promotion and everything. But there is much more, needs to be done. So that will be visible in your process flow diagram or in your value stream map. So if needed, we will use the process flow diagram also, nothing wrong. But the purpose of Sipoc is to convince the sponsor. I am telling my sponsor indirectly that, sir, this is where I am going to work. Isn't it? Otherwise, what happens? You will be spending your resources in a wrong place and then ending up achieving nothing. So that should not happen.
And
So-
one more thing, Sipoc is certainly for arcade to teach you one more philosophy. You know what is the philosophy? Everybody is a customer. Everybody is a supplier. One day I am going to be your customer. One day I am going to be your supplier. So
Yes,
you will have to give respect to everybody. This is a philosophy. I'll teach you more on it. Right? Thank you.
And also a process owner, sir, he himself.
Yeah.
Yes, all three will be there.
Yes.
Himself supplier, himself customer, himself a process owner.
Yes. You go to a restaurant and then you are taking the dinner with your children on the dining table. Now, who is the customer and what is the output? The output is your after eating the food, no, what you are keeping it in the table. That is the output. And who is the customer for that? The waiter. If you don't eat it properly and spill everything and then it's a nasty table, the customer will be unhappy. He will curse you, right? Therefore, keep everybody as a customer and take your food neatly. Follow discipline, even while eating outside. Thank you very much.
All right. So 1 minute.
Yeah, this is not necessarily in restaurant, even at home, no? Customer is wife. So eat properly. Don't leave anything out. And always keep
good.
praising also sometimes.
Good information.
Customer is the king, yeah. Keep that in mind forever. Oh, Sipoc is hopefully clear, right?
Yes, yes.
What does Sipoc do? Sipoc teaches us a philosophy of being polite to everyone. Sipoc teaches us the responsibility for every process, a bird's eye view of what is taking place, and it will help the process sponsor to sponsor the project.
So all of you, can you see my slide?
Yes.
Yeah, yeah.
Yes.
So just this is only again, I don't want to get into the complete details because we are just done with the define phase. The measure, analyze, improve and control. Once we finish, probably you will be able to appreciate better. But now I just want to spend some time with all of you so that you get a picture of how a DMAC project will run. All right. So, okay. So this is a case study where the team is focusing on reducing the rejection rate in the die casting industry, right? A manufacturing company where pressure die casting is used. And see here the problems. What are the problems they are trying to address? Blowholes,
Blowholes,
poor surface finish, and then improper filling.
Improve filling.
filling.
3 types of defects, and they have taken it together. There is a reason behind. And the CTQ here is, in fact, it is a CTB. We already discussed the rejection rate or the rework rate. And the images are also given here. You know why the images are given? Project team can have a clear understanding of the nature of the defect, isn't it?
Yes.
It means what does it take? Poor surface finish means what it is. And improper filling means what it is. So that clarity has to be there. First of all, the team should have a clarity on the problem. And now the project charter. I'm not showing everything, but the business case is written here. Can you see the business case here? What is the saving?
18.27.
18.27. And over and above, some additional benefits to the organization, like it helps in improving the customer satisfaction, on-time delivery, 5S audit score. And then the problem statement is rejection rate of a particular part, which is known as ARTAS body. Currently, it is 15.5, and we are trying to bring it down to 7.75, right? Close to half of it. And within 4 months of time, and the scope statement, in scope and out scope. So the specific part is chosen and specific type of defects are chosen for remedy. And all other parts, all other defects are excluded in the project. Maybe they will be taken up in some other project. And now the timeline, team member, signature, and all those things, you can imagine. And now measure phase. While measuring, what you are seeing here is a kind of measurement system validation. This is called attribute agreement analysis. All the appraisers have to check in the same manner, isn't it? If there are quality inspector,
Yeah.
if I say the product is good, then other inspector should also tell the same thing. So if two appraisers are not agreeing to each other, this leads to an error called reproducibility error. If I myself, one time I say a good as good, the other time I say good as bad, that means I have a repeatability problem.
Repeatability.
So the repeatability error as well as the reproducibility error will lead to ultimately the measurement error. A good product should not be rejected and a bad product should not be accepted. These are called type 1 error and type 2 error in measurement. Depending on the data type, we have two types of analysis. If the data type is attribute data, the analysis is attribute agreement analysis. If the data type is continuous, the analysis is known as gauge R&R. We will be discussing it in the next phase of the DMAT, which is measure. So after ensuring that the measurement error is as per the standard, the industry standard is measurement error should be lesser than 10%.
10%.
Once that is ensured, you can collect the data and then verify the problem. That means an accurate measurement of the baseline is now collected. You see, according to the project, when the project is started, the rejection rate was 11.4%. This is how the team has started. While the project was initiated, the team was of the assumption that 11.40 is the rejection rate. But after the project is approved, they actually collected data. They actually collected data for about, you see here, 1.5 months time. For about 45 days, the data is collected. And after collecting data for 45 days, they realized that the rejection rate is not 11%. The rejection rate is 15.5%. Problem is verified and problem is, upgraded. Problem statement is now updated. Can you see that, all of you?
Yeah.
So this is one purpose of the measure phase, right? So we verify the measurement system. We also verify the existence of the problem. Sometimes a problem may not even exist. That is also possible, isn't it? People think that the rejection is 10%, but actually it may be only 4%. Then why rejection is projected as 10%? Measurement error. You correct the measurement system, that is your project. So that is also possible. But here in this case, 15% is accounted as, it was understood as 11%. The same thing expressed in terms of DPMO. Hope all of you by now you know how to convert it, right?
Yes.
The number of opportunities, the number of pieces inspected. Since there are 3 defects they are interested in, number of opportunities 3. They have inspected 6,761 pieces and identified 1,048 defects. Now you have the calculation. You can calculate, and sigma level is found to be 3.1 and DPMO is found to be 51. This is 51,000. This is called baseline performance. Once you are ready with accurate measurement of the baseline, the measure phase is over. So the measure phase deliverable is 51,000 DPM. Clear? Now we proceed to analyze phase. So in analyze phase, this is cause and effect diagram or fishbone diagram. And now all possible causes are listed. And you can have the causes categorized into 6M sometimes, men, machine, method, material. You can also always have your own categories, nothing wrong, no hard and fast rule. So after fishbone diagram, some of the causes are picked up, hand-picked, based on the stakeholders' opinion, experts' opinion. Wherever, whatever factor which are more suspicious, they are taken for the next level. The next level is validation. For each of the root cause, validation. So for validation, a procedure is created. See here, for some factors, validation is GEMBA. GEMBA means physical verification. We go to the spot and then verify. And for some factors, the existing data or some data collection method is used. Data collection means some experimental verification. And then experts' opinion is also taken here for certain thing. And for certain factors, look here, dye holding time, improper pouring time, and dye temperature. All of these are really complex factors, and so regression analysis is recommended. Nothing but a hypothesis testing. And then for composition of material, the incoming raw material quality checking. For that, third-party inspection is recommended. All the material supplier raw material coming, if there is a problem with the raw material composition, then that can lead to the poor casting quality. So that is also tested. And finally, improper maintenance. For improper maintenance, the maintenance report, how the team is actually doing the maintenance. The document is used as the validation method. Now for each and everything. And the first one is, what is the problem they are saying? The ladle, the ladle size, and it is verified that the ladles are really insufficient. There is only one ladle per die, but at times what happens, additional ladle is required, and under those time, people use the alternate ladles, which are not meant for that particular die, isn't it? So as a result, what happened? They end up pouring excessive quantity or end up pouring a shortage of
Less
the
quantity.
Yeah.
Less quantity.
So that leads to your problem. So that is really validated. And then process knowledge. The people who are working there, they lag in terms of the process knowledge. So that is all. These are all verified just with the help of Gemba work, physical verification. And then data is collected to study the pouring time. So for that, some experiment is conducted for 3 days using 2 different operators. 3 days, 2 different operators, and lot of data is collected. Maybe several castings were produced, and so there could be hundreds and thousands of data available. And they realized the lowest time taken is 1.59 seconds. The highest time taken is 2.63 seconds. Now, how much is the difference?
1.04 seconds.
So the team, is they have convinced themselves that this 1 second may not be the reason for the poor casting. So they don't want to investigate further. So they took it granted that pouring time is not significant. So they have written insignificant. You can see that.
Yeah.
It's insignificant. So next. Now here, whether die holding time has any relationship with rejection rate. And you can see the R square of 97%. R square value. We will be dealing this, we'll be learning this under correlation and regression analysis. An R square value of more than 80% and a p value of a lower p value. An R square value of more than 80% and a lower p value. Sometimes it is less than 10%, sometimes it is less than 5%. Here it is less than 10%. You can see 0.65. That means 6.5%. Lower p value, higher R square statistically confirms that die holding time is related to rejection rate. So you now have the a reason to optimize the die holding time. The amount of time the molten metal spends in your die, right? The die holding time. So that is now understood as significant factor.
Significant.
So for all the die, all the castings, the molten metal has to spend only exactly the prescribed duration of time. Slightly in excess, slightly in lower level, the casting quality will get affected. So you are not supposed to keep varying die holding time for the castings. All the castings should have the same die holding time, and the optimum value has to be arrived. Right now, we realize that it is significant. Same manner, the improper pouring temperature. For different pouring temperature, castings are produced and the relationship is found. And again, can you see the p-value? P-value is low. P-value low, so the factor is significant. At the same time, R square is also very less. It's not more than 80%. So R square not only check the significance, it also check the sufficiency of the factor. Here, we have considered only pouring temperature. Actually, the casting quality not just depends on pouring temperature. It also depends on other factors also. So, however, we have now studied only the pouring temperature, the influence of pouring temperature on the rejection rate. So that's the reason why R square is low. So if you really want a higher R square, you have to consider many factors. Many factors in the sense, all critical factors have to be considered in your study. Then only R square will go up. Similarly, dye temperature. The dye temperature is also found to be significant. Just look at the p-value. Right now, don't look at the R square simply because the experiment is conducted considering the factor one at a time. We have conducted the experiment considering the factor one at a time. Automatically, R square will be lower. Only if you consider all the factors, R square will improve, isn't it? So only look at the p-value. P-value is less than 5%, and so that is significant. So dye temperature is significant, pouring temperature is significant, and then dye holding time is also significant. So all the three factors are measurable characteristics. Measurable characteristics means continuous. So all the three are critical. When all the and so the significance is verified, validation is done. Now the third party testing. The third party testing of the raw material has confirmed that the material is well within the standards. BS 1490 grade LM 24. And you can see the obtained value and the required value, all the parameters are acceptable. So no issues with the supplier raw material quality. And now here is the validation. You see, only few factors are not getting validated. They are considered insignificant. So the incoming raw material, no issues with the incoming raw material. And then delay during the pouring metal, there is no delay. Almost every casting, the pouring time is close to 2 to 3 seconds only, and there is no issue. Similarly, the injection pressure is also considered to be, and they have not done anything. See here, simply expert's opinion is taken, and they considered that one as insignificant. And so now we need to develop solution for all the validated factors. For each of the validated factors, what is done here? YY analysis is done. The power of YY is, if you go to the fourth Y or the fifth Y, the solution will become very obvious. And see here, insufficient short volume. People, they pour based on assumption. And why they are pouring based on assumption? Because they are using the ladles meant for other dyes. Why they are using the other ladles? Because there is non-availability of ladles. So what can be, so why there is non-availability of ladles? We are not keeping extra ladles. So what will be the solution for this problem? Come on, what will be the solution?
Extra
ladder.
Extra ladder.
Extra ladder will be
Very good.
Ladder.
So that's the power of YY analysis. Tools can be helpful. So same manner, solution is developed, and then for each and everything, for insufficient short volume, solution is keep extra ladle. Then for lack of process knowledge, training of the operator. Then die holding time, find the optimum level. When I say optimization, the tool required is DOE. Moreover, why DOE now? Because the die holding time is a continuous characteristics. I mean, measurable characteristics. This is also measurable characteristics. Die temperature also measurable characteristics. And moreover, they are interdependent. Am I right?
Yes.
They change one, then the other one will also get affected. So, under those situations, you cannot study the factor one at a time. You have to study them simultaneously. So DOE is recommended, right? And then for improper maintenance, the CLIT maintenance procedure is recommended. That means cleaning, lubrication, inspection, and tightening of the machineries and die, etc. have to be done by the operator themselves on a daily basis. And then to take care of the temperature of the die temperature has to be at a particular level during the casting production process. So some preheating procedure is initiated. So at frequent interval, the die will be preheated. So these solutions are suggested, and then they were actually implemented. You can see here additional ladles provided, and then operator training is happening, and then die preheating arrangement is made, and then the CLIT maintenance is created, and then that is also in practice. And then for the dye holding time, dye temperature, and the pouring temperature. 3 factors. Each factors is set at 3 level. Dye temperature is varied from 800 to 900, 800, 850, 900. So 3 factor, each 3 levels. First factor 3 level, second factor 3 level, third factor 3 level. 3 into 3 into 3. How many? How much?
9,
27.
27.
9.
So minimum 27 experiments have to be conducted. And in order to avoid the experimental error, each experiment must be replicated at least twice. So 27 into 2,
54.
54 experiments have to be conducted. 54 castings have to be produced under these conditions. And now they realized, no, this is the impact. This graph is clearly explaining about the main effect of each of the factor. The main effect of each of the factor. And now the graph is telling that the rejection rate will be minimum when the pouring temperature is 800. Can you see that?
Yes.
The rejection rate will be minimum
Linear.
when the dye holding time is 12
12.
seconds or something.
Linear.
Yeah.
Linear. That one.
Yeah, 12.
Dye
And
holding.
the temperature, the rejection rate is minimum when the dye is maintained at a temperature of
195.
195.
So solutions are arrived. I mean, optimum values are arrived after DOE. So DOE is a complex tool. You will be learning during the 3rd week. So then after the experiments are done, the optimizations are done. And again, data is collected. You can see here. Again, data is collected. I mean, this is original data, 15.5% rejection. And then the data is collected. And now the rejection rate has come down below 5%. Can you see that?
Yes.
Rejection rate has come
Yes.
below 5%.
0.38.
And this is a kind of solution validation, right? Some 15%, it has come down to 4.5%. And then these are the control plan. The same problem should not happen again. So what needs to be done? Some monthly rejection reports are, the company started taking the rejection report, and training is in place and the maintenance is in place. Some additional monitoring and all the X factors will be monitored at regular interval. Thereby the problem cannot shoot up again. So this is how the flow will be, and these are the improvements achieved. So sigma level improved from 3.1 to 3.7, and rejections reduced from 15.5 to less than 5%, with a saving of direct saving of 12.7 lakhs. However, the total saving is 18.27 lakhs, because there are some non-financial benefit that is they are also accounted finally. And the production rate also improved, and this has led to an annual saving of so much minutes and so excess saving. And both put together, the saving is 18.27 lakhs. So this is an illustration purpose, how a project flow will be. However, if you learn all the tools, then you will be able to better appreciate. So I think now you have some clarity on how to draft your project charter and how the project flow will be. All right.
Yeah.
So that's it. So any question you can ask, and RK sir, you can answer the questions.
Yes.
All right. Okay.
One second. I'm not leaving. I'm coming.
All right. So
Yes. Questions.